Right then, let us talk about the limits. Say, for instance, you are given a question that says, show that limit, show that a limit of root of 4x squared plus 1 divided by x plus 1 is equals to 2 as x tends to approach infinity. Okay, say you have a question like this. It says to us, show that the limit of this expression is equals to 2 as x tends to approach infinity. So now, most definitely, we are looking for limit of this. This is our final answer. So we are looking for 2 using this. We're going to evaluate this to determine its limit. So in order for us to do that, let us take this left-hand side, okay? Because we are proving, most definitely it's showing. So we're going to take the left-hand side. We're going to say our left-hand side of the equation is equals to limit of root 4x squared plus 1 divided by x plus 1 as x tends to approach infinity. Therefore, we're going to say this is equals to, now this is what is happening. If you do a direct substitution, whereby you're going to substitute your infinity onto this equation, infinity plus 1 is going to be infinity. And therefore, everything divided by infinity, it is math error. So in this case, that means we can't do a direct substitution. So now what are we going to do to determine this limit? Now, we look at our denominator and then we divide by the highest degree or highest power. A variable that has the highest degree or a variable that has the highest power. In this case, we only have x to the power of 1. So that means we're going to divide the whole expression by x to the power of 1 before we can even substitute this. So that means we're going to continue with our expression. We're going to say limit root of. So now this is what is happening. I want to do this first, okay? As x tends to approach infinity. So that means here we're going to say x divided by x plus 1 divided by x, because I said we're going to divide every term by x. So that means x divided by x, 1 divided by x, and then let's talk about what's happening under the root sign. Now, this is what is happening. It is true, we're going to divide 4x squared by x, but the problem is when x gets into a root sign, it becomes x squared. Why am I saying this? Now, you can recall that x squared out of a root sign, it is x squared. But now x squared under the root sign is going to be equals to x. So that means x on itself, it is x. But when I take x under a root sign, it's supposed to be x squared. So that this root sign can cancel this squared and then it goes back again to x. So that's why we say when you take your x under a root sign, it's going to be x squared, okay? Plus 1 over, that means we're going to divide by x, but because now it is under the root sign, it is x squared, okay? All right, so now here we have a limit root of x squared, cancel x squared, and then we left with 4, and then there we still have 1 over x squared divided by x cancels x, we left with 1 plus 1 over x as x tends to approach your infinity. And therefore now we're going to substitute infinity where we see x. So that means 1 divided by infinity will say this is 0, and then this and that will say 0. That means here we're going to have 4 plus 0 divided by 1 plus 0. Now, as I continue with my left-hand side, what is 4 plus 0? Most definitely here we're going to have root of 4 divided by what is 1 plus 0? It is most definitely 1. And therefore, root of 4 is 2. 2 divided by 1, it is most definitely 2. Therefore, we can simply say that, we can simply conclude and say that our right-hand side is equal to our left-hand side, where we show that the limit of this expression is equal to 2.